Alright, we're now going to start talking about what the actual normal distribution is. As you can already see the picture here on the screen, probably many of you have seen the normal distribution, but you probably haven't maybe talked a lot of detail about how it works and what certain things actually happen with it. So we're going to start by giving a little introduction of what that actually is. So to understand, the first thing we're talking about is when is a z-score actually big? So what would be a very unusual z-score that we were calculating before actually be? So first, as a little reminder, what a z-score was this one formula that we've had so far, where we have this z equals our y minus our mu over our sigma, right? So that was our formula we were talking about before. So the normal distribution is actually what's called a model. So let's first talk about what a model actually is. So a model is just a way to describe how data is expected to behave. So this is an idea of what to expect. A specific model is called the normal distribution or the normal model. As you can see from the picture, we usually refer to this as a bell-shaped distribution. There are two different things that we have to know for a normal distribution. We need to know its mean, which we've seen this before, at least the symbol before, and we need to know the standard deviation. So both of those symbols showed up here in our z-score that we've seen before. It's symmetric about the mean, which means that 50% is below it, 50% is above it. So it cuts the data right in half. And so if I first start on there with my picture, that's where this little line down here actually occurs, or in a sense is up here where that peak of the distribution actually occurs. That's where our mean is. Now, from this normal curve, when we start at the mean, we actually know some different things that have to be true. So there's this thing called the normal curve rule. So it's true for any normal distribution. So as long as it has this shape to it, it's going to be true. We know that 68% of the data is going to lie within one standard deviation. Okay, so what does that actually mean? So if I start at the mean, and we go a standard deviation below it, and we go a standard deviation above it. So in a sense, this is going to turn out to be whatever the mean is minus the standard deviation. This will turn out to be whatever the mean is plus one standard deviation. And if I go out that far in either direction, this is going to be 68% of my data. Or so 68% of my observations or my data will lie between whatever this number is and whatever this number is, down at the bottom. Right, 95% of the data lies within two standard deviations of the mean. So what that means, I go down to my picture here, and I go out another standard deviation below it, and another standard deviation up above it. So math-wise, this is going to turn out to be me minus two standard deviations. This one's going to turn out to be the mean plus two standard deviations. And when I do that, 95% of my data will be between those two numbers. And then finally, if I go out three standard deviations, I'm going to get almost all of my data. I'm going to get 99.7%. So there's going to be very little left that I don't have. So I go out another standard deviation here, and another standard deviation there. So that's going to be the mean minus three standard deviations. This will be the mean plus three standard deviations. And if I do that, we're going to get 99.7% of my data. So from this picture, if I look at just where my green lines are, so between here and here is almost all of my data. There's going to be 0.3% left over that falls out on either side of my picture. All right, so that's the idea of this normal curve rule. What we're going to do with your other picture that you have at the bottom of the page that I have on my next page here is to take the same picture and just break it up into a slightly different way. So we're still using the 68, 95, and 99.7 that you see here. All right, so with this same picture, let's break this picture up. So the first thing I'm going to do is I'm going to put the same things along the bottom. So I'm not going to change that. And I'll even use the same colors if that's helpful. So we're going to start with the same numbers along the bottom. What we're going to do is just take this and break it up into a whole bunch of pieces. So I'm just going to draw lines where all of those occur. Alright, so if you look at my picture here, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And what I'm going to do is I'm going to start in the middle and work my way up. So from our previous picture, we know that 68% is between this mu minus a sigma and the mu plus a sigma. We also know that my graph is symmetric. So from this picture, I also know there's going to be 68% between these two numbers. But I have two different spots to put it in, but since it's symmetric, the same amount is going to go in to both pieces. So if I take my 68% and divide that by 2, I'm going to get 34%, and that's how much is going to be in each of these pieces. And then I can also see if I add those two, right, I still have 68% between these two numbers, just like with my previous picture. Right, now it's going to get a little bit trickier. When I go out from the blue, from our previous picture, we know if we go between here and here, we should have 95%. So between, again, here the blue one and the blue one will be 95%. So between these four pieces should be 95%. Well, the problem is I've already put some on here. How much have I put on here? I've already put 68%. So I'm going to first start by subtracting that off. So 95% in all four pieces. I've already put 68% in two of the pieces. So I can only add 27% more between these two pieces. Again, it's symmetric. So I'm just going to divide that by 2 to figure out how much is put into each piece. So here I'm going to have 13.5%. Here I will also have 13.5%. And again, if I add up all four of those numbers, I still get the 95% that I had on my previous picture. Finally, with the green, we know that between this value and this value is 99.7%. So that's the total amount I can have. But now at this point, we've put on 95%. So we only have 4.7% left that we can add to the picture. Again, two different spots to be able to put that in. And so that we're going to find that in each of those pieces, we're going to have 2.35% in each of those. And again, I add up all the numbers I have so far, I get 99.7%. Now, so we're not quite at 100, but we can also get actually 100% of our picture because we still have these two tiny little pieces left. So how much should I have in total? Well, we should end up with 100%. So far on the picture, we've put 99.7%. So we only have 0.3% left to add to the picture. Again, 2 spots to put it in. So in each of those little pieces, we're going to have 0.15%. And then my picture will add up to 100%. Alright, so far we've only been using these symbols of mu and sigma, so let's talk about how this rule would actually apply to a problem. So for our example, we know that the number of points that Kentucky scores in a basketball game is relatively normal, with a mean of 75 points and a standard deviation of 8 points. And actually the first thing you'll see that I did here was a little bit of shorthand notation. So let's break this little thing down. So I'm going to write it up here so I can write it a little bit bigger and talk about each piece. And we're actually going to work backwards. The 75 is the mean, is our mu, and the 8 is our standard deviation, so that's our sigma. This n just stands for that it's normal, or basically that it has that bell-shaped picture that we were just looking at. Y here represents our Kentucky score. Right, so Kentucky scores are what we're talking about there. And then finally, probably the least important part here is this little squiggly technically means that it's distributed, or basically that this is what its picture looks like. So what we're saying here is Kentucky scores look normal, so they have this bell-shaped symmetric distribution, where the mean is 75 and the standard deviation is 8, and we're saying all that with this little binky symbols. We begin to see this notation more and more throughout the course, so I like to introduce you to it early. So the main thing is like this is what we're actually interested in. This just means it's symmetric and bell-shaped, so it has that picture that we're looking at. And then I always have to give you the mean and the standard deviation to be able to work with it. Now, knowing that, we want to figure out what percent of Kentucky games will they score between 67 and 83 points. So I'm going to start with a picture because I already know that it's normal because it told me that in the problem here. And I'm going to sort of draw the picture we had last time, but now with the actual numbers involved. So our mean, which is what goes in the center here, is 75. And our standard deviation is 8. So each time I go to the left here, I'm going to subtract 8 each time. So if I take 75 minus 8, I'm going to get my 67. 67 minus 8 will get me 59. And finally 59 minus 8 will get me 51. I'll do the same thing going up. So we're going to add 75 plus 8. So 83 plus 8, 91 plus 8 to get our numbers along the bottom. So this is just looking at the same idea that this is doing along the bottom. So just finding those numbers there for us. Now we want to find between 67 and 83 points. So this is what we're looking for. So now we can go back and look at either of our previous pictures to figure out where that corresponds on our pictures. Here, probably the easiest one is to realize we went one standard deviation in both directions, so that this is going to turn out to be 68%. Or you could go back to the previous picture and just find the two different 34% and add them back together. So then we can say that in 68% of games, Kentucky scores between 67 and 83 points. So now we have an idea of what to expect. So 68% of the time, they're going to score between 67 and 83 points. All right, a little bit harder. We want to find what percent of Kentucky games would they score more than 59 points. So I'm still working with the same mean and the same standard deviation as above, so all my numbers on here I'm going to put are going to be exactly the same. So we're still going to get our 67, our 59, our 51, our 83, our 91, and our 99. And this time we're interested in 59 or anything higher. All right, so everything. Right, now there's different ways to put this puzzle piece together. What I'll first note is that the 59 is 2 standard deviations below the mean. So if I also go 2 standard deviations above the mean, between here and here, that's 95%. Right, because it's 2 standard deviations away from the mean. So I'm going to get this blue idea that I have here. Now what I haven't taken into account is I still have this other little piece here that I want. Well, if there's 95% between here and here, there's 5% left over and 2 spots to put it in. So over here is 2.5%, and over here is 2.5%. Or from my previous picture where I'm getting that is by adding this 2.35% and that 0.15% together. So it's that both of those little pieces that I need on this picture. So then in total, I'm going to get 95 plus 2.5%. So we're going to get 97.5%. So then we could say that in 97.5% of games, Kentucky scores more than 59 points. All right, another example. A smart thing to usually do, and I'll say this a lot during videos, is sometimes maybe to pause the video and try one of them on your own, and then you can check to see if it matches. So if you feel pretty good with the normal curve rule, it'll be a good time to sort of pause it and check to make sure that this one makes sense. But of course, I'll go ahead and work it in case you decided not to pause the video. So again, we're still working with Kentucky scores, so my picture is not going to change at all. So I'm going to start by putting my same things on here. And this time we want between 83 and 91 points. Now, if you're lucky enough to be using your notes, which unfortunately doesn't get to happen on quizzes and tests, you can easily look at this picture and say, oh, that's between here and here, it's 13.5%. Now, usually it's going to be very hard for you to have this picture memorized when it comes to taking a quiz or a test. What you generally will have memorized is the 68, 95, 99.7, right? If there's only those 3 numbers you need to remember, if you know these 3 numbers, you can recreate this picture anytime you want. So let's actually figure that part out again from that way. So I would know that if I went between 67 and 83, that's 68%. I also know that if I went from 59 to 91, I get a total of 95%. So again, this piece plus this piece I actually want, and the 68% add up to that 95%. So from there, what I could do is, okay, well, I need 95% in total. Let me get rid of that 68%, and I get my 27%. But then again, I have those two different spots to put it in. And so I could come up with this 13.5% again, being this piece and this piece, then realizing that this is the only piece I actually wanted. So then I could say in 13.5% of games, Kentucky scores between 83 and 91 points. There's a few different examples of using the normal curve rule to come up with some probabilities, but I want to talk about some specific things about these ones that we found. So to understand that, we're going to talk about the z-scores for the above values. Or in a sense, let's look at, from my original picture, what's going on. Right, so I have this 75, 67, 59, 51, this 83, this 91, this 99. What happens when I take each of these numbers and plug those in to my formula that I have? Alright, so let's start with the 51. So we'll take 51 minus our mean of 75. And going back, if you don't remember, our standard deviation was 8. That was given to us there in the problem. So that's what we're going to divide by. What do we get? -3. Well, what does a z-score measure? It measures the number of standard deviations you are from the mean and in which direction. So this -3 is telling us that that 51 is 3 standard deviations below average. 1, 2, 3. 3 standard deviations below average. So what's going to happen when I plug in the 59? Well, if I look at my picture, I went 2 standard deviations below. So I shouldn't be too surprised here when I get -2. Because if the negative, it means it's below. And it's 2 standard deviations below average. So for each of these numbers, if I plug it in to z, the 51 gave us a -3. The 59 gave us a -2. What would the 67 give us? 67 minus 75 over 8 would give us -1. 75 minus 75 over 8 gives you 0. 83 minus 75 over 8 gives you 1, 2, 3. So I'm really looking at number of standard deviations it is away. That's what that z is exactly doing. So why do I bring this up? At some point, we're going to worry about numbers that aren't a perfect number of standard deviations away. But if we can look at the ones that are these exact and use those as a reference point, that's going to help things make a lot of sense. In class next time, we're going to talk a lot more about how the mean and standard deviation can affect things. Not only how your picture looks, but how it affects the probabilities as well.